All right, guys. So previously, the last lesson, we did up to the left side. So today, we're going to do the right side, okay? So the right side means you're converting from what graph to what graph? Very good. You're converting from what? Speed time graph to acceleration what? Time graph. Very good. So we're converting from speed time graph to acceleration time graph. So right now, if you look at your notes, the 5 graph means you're going from top to bottom or bottom to top. You're going from where? Top to bottom or bottom to top? Top to bottom, because you're going from speed to acceleration, correct? So right now, let's look at the first one. So the first one, we're going to highlight in pink. Here. So if you convert, if you look at it, is it number 1, number 2, number 3, or number 4? So number 4 means what? How will you draw your graph? So right now, I want you guys to start drawing for me. So draw the pink one. After that, draw the orange one. And then draw the blue one. So go draw it now and let me check. Okay, so everybody has gotten the shape already. But now, this is a what graph that we want? The question wanted you to draw what kind of graph? Acceleration time graph means we need to find the... So we need to find the acceleration. So how do we find acceleration from a speed time graph? Very good. Gradient or slope, remember. So how to find gradient of the slope? So let's look at the one in pink. So I want you guys to go and find the gradient of the pink one right now, the orange one right now, and the blue one right now, and let me mark. Okay, so everybody has already gotten it. So right now, let's recap again. What's the one in pink? The gradient. So -6 means I know it's somewhere here, -6. Next, the one in orange. 0, so I fill in. 0 is here. And lastly, the one in blue. 5 over 9. So a lot of you guys never draw in proportion. If you know that the gap from 0 to 6 is like this, do you think the gap from 0 to 5 will be bigger or smaller? Huh? Smaller. So I notice a lot of you guys are not aware of the proportion. The proportion, it must be proportionate. So from there, we already know the shape. So you must always draw in dotted line to separate out the 3 different zones. So draw in dotted line to separate out the 3 different zones. The one in pink will be a straight line here. The one in orange will be a straight line here. And make sure you draw thicker so that your teacher can see it's actually being drawn. Otherwise, your teacher say that you never draw at all. Do you understand? It must be thicker than the x-axis. And lastly, is here. You must draw until this 15 mark. Can you see this 15 mark is right up to here? So you must draw up to the 15 mark only. That's it. The end. So right now, we're going to start applying to the question, the 4 questions. Okay, let's go. So in this question, let's read the question. What did they say? If you read the question, what did they say? Guys, let's read the question. What did they say? Yes, a speed time graph. And then you stop there. Speed time graph. So we check. Is it a speed time graph? Yes, it is a speed time graph. Next, what else did they say? Like who? So we have how many items going on? What are 2 items? We have a car. So if I were you, I will highlight my car in one color. So I know that all those in red belongs to just the car. And then I'll highlight my lorry in another color. So I know that all those in yellow is my lorry. So like this, I won't be confused when I'm looking at many, many different numbers later or different graph later. Now, what did they say? The key thing is they say that it is for a period of 100 seconds. So let's look at it. Is it really up to 100 seconds? Yes. Can you see here? It's up to 100 seconds. Okay, so that's not really that important yet. So continue reading. What did they say? So 15 meter per second, can you see here? 15 meter constant speed means they're talking about the meter zone for the car. So you must read the question. And then after that, what did they say next? Before decelerating to a stop. So they say 40 seconds. It matches. Can you see? The speed of 15 for 40 seconds. It matches. Okay? And after that, they say decelerate to a stop. Means it's trying to tell you that it will slowly go down, slowly, decrease the speed until it what? Guys, until it stop. So I know the car stopped. But the lorry, what did they say about the lorry? So the lorry just continue going. It's always moving at a constant speed. It never go up, never accelerate, never decelerate, never stop. So you have to understand this graph. If you don't understand, always read the question. Okay? So right now, we'll move on to the next part. So what is the question asking for? Let's read for question A. They're asking for they want the time. So time means what? The x-axis or the y-axis? The x-axis. So I need to know where the time is. So the time is 10. 10. So I know that this is around 10 seconds. Estimated there. So 10 seconds, if I dot until the graph, it means that this is the speed I want to find. The question mark. Can you all see that? Right? That is the speed I want to find. So I know roughly, if you look at it logically, your answer will be around how much? If you look at it logically, you know that the answer you're looking at should be around how much? Oh, yeah. We're finding time. So they say find the time when the speed, oops. I read as the time is 10 seconds. Okay, so find the time when the speed of the car is 10. So the speed of the car is 10. Where's the car at 10? Can you see this is at 10? Means this is the time that we need to find. Question mark. Is that all? If you say that's all, you are wrong. Is that all? Huh, guys? Why no? How come that is not all? For the time. The keyword is speed of the car is 10 meters per second. How come that's not all? Who knows? So that's not all because there is one more part at 10 seconds. Means at the end of the day, how many answers must I have? 2. So if I were you guys, I won't put a question mark. I'll label this as T1 to remind myself there are 2 answers and T2. So for T1, I'm going to focus on just here first. So this is how I'm going to find the answer for T1. So guys, whenever you find T1, this is when you learn coordinate geometry. Because why? I actually have this coordinate that is given and this coordinate that is given. So what is this coordinate that is given? And this is what I need to find. And this coordinate is also given. So what is the first coordinate that is given? Okay, shouldn't take too long. You already learned coordinate geometry. So tell me, what is the coordinate that is given for the first one? 0, not 0, 0. It's 0, comma 0. What about the last one that is given? What about the last one that is given? What? It's not just 20, no? Speedy, speedy. Guys, not just 20. Come on, speed up, faster. 20, 15. Very good. Now, the one that I want to find, what do I label it as? The coordinate. What do I label it as? I thought I labeled for you guys already. Why tell me X? Yes, T1 followed by comma and T1 comma T2. Girl, wake up. So it's T1 comma 10. Yes. So right from here, what do you notice? What does these three coordinates share? They share the what? You learn coordinate geometry already. What does these three coordinates share? Very good. They share the same gradient. So these three coordinates, I know that they share the same gradient. So it means that I'm using the same gradient concept. And you have to know this because in DST, there is a lot of this kind of question. So what is the same gradient concept? So I know that the gradient of this coordinate and this coordinate will be the same as the gradient of this coordinate and this coordinate, right? So let's do the gradient of the one in tick first. So let's do. Gradient of the one in tick is the same as the gradient in the one in arrow. So someone tell me, what is the gradient for the one in tick? Yes, next person. Next person, someone else that's different. Let's go. Oh, come on. Yeah. 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 Yes, so now let's simplify. So what's the answer? One need calculator, no need calculator. Come on, guys, let's simplify. Yes, 15 over 20 equals to 10 over T1. Then what do I do from here? Cross multiply. That will give me 15 T1 equal to 200. And therefore, I know that T1 will be equal to, now you can use your calculator. 13 1/3 what? What's the unit? You can just say 13 1/3. 13 1/3 what? Huh? Second. So right now, this is the T1. We also have a space. I want to write the other side. We also have a T2, right? And T2, what should you do before I start solving? What do you notice? That's what I did. So draw out first, and after that, label the how many coordinates in total? So you have one coordinate you got to label, two coordinates you have to label, and three coordinates you have to label, right? Okay, go. Start doing that now. So do ready, let's mark. So do not look at the screen for answer. Do ready, let me mark. Okay, guys, so check your answer with the one on the screen. So this is the answer that you guys should get. So we already know that there's T1 and T2. So as usual, you need to have a very good habit. Guys, look at the screen. So can you see the T1 and T2? I will erase and I'll fill in the answer. So at T1, what's my answer? 13 1/3. Fill it in. And then at T2, what's my answer? 73 1/3. And then fill it in. Okay, so right now I'm going to erase the rest. Okay, so right now we are done with A. Now we'll move on to question B. So let's look at question B right now. They say that find the speed of the car 10 seconds before it comes to a rest. So you need to be really, really careful for this. Okay? So right now, guys, look at it. They say 10 seconds before it comes to the rest. We know where it's resting, correct? Where is it resting? At what second? Yes, it's resting at 100 seconds. So what is 10 seconds before 100? So 10 seconds before 100 is at 90. So this is the blue color point that they want to find. So I'll dot. The clue that they give me is at 90 seconds. So of course I fill it in. And what does the question want? The question wants is the what, guys? Huh? They want is the speed, which is the X or Y axis. Y axis, so it must be in dotted. So let me go and make it into dotted. Dotted. So all the dotted line. So the dotted line all the way until you need to find the speed. So speed, I'll put question mark. So this is the speed that I want to find. So you know roughly when you find to see whether your answer is correct or wrong, your answer must be around how much? If you roughly look at it. You know that your answer must definitely be less than 5, or a definite one is less than what? If you use the numbers here. Less than 10 for sure. So if you get more than 10, it's wrong. You get a negative number, also wrong, because speed can never be negative number. Like just now, someone got a time is negative. Can even time be negative? So it's not, it's logic, you already know. Means you know that you're in the wrong track. Right, guys? So if you look at it, guys, here, just now the answer, you know that your answer must be between 60 to 80. So if the question A, your answer is not between 60 to 80, means you know you're wrong already. So you must use a little bit of logic. So right now, let's go. You know that your speed answer must definitely be before 10. Now, what do you think you can do for question B? Do you think you definitely can do question B already? Yes or no, guys? Will you be able to do question B? Yes or no? Guys, do you think you can do question B? Yes or no? Have I already taught you? Have I taught you? Guys, have I taught you on how to do question B? Yes, right? So go and do question B and let me mark now. All right, guys. So question B, can you tell me, question B, how do y'all do question B? You see, never use the concept. So what's the concept that I taught you guys to do question A? It's called a what kind of concept? Same gradient concept. Yeah. So question B, is it the same as question A? Yes, right? So question B means what concept are we using to apply? Also the same gradient concept. So question A and question B is similar because they are all lying on a straight line with coordinates that was given to me. So right now, question number C. Please take note, okay? I don't want anybody to make this mistake because question number C is a very typical exam question. The keyword is the car overtake the lorry. Now, the moment you know you see the keyword overtake, what does that mean? What is the same? The moment they tell you the car overtake the lorry, it means something is the same. What will be the same? For the car to overtake the lorry. What? Very good. Means the car and the lorry must have the same distance. So a lot of students make a mistake. They say that the answer is here and here, the intersection point. Is it correct or not? If you look at the intersection point, what is actually the same? For this graph, the intersection point, what is the same? Yes, very good. For the intersection point, the speed is the same. But the question say, I want to find the point where the speed is the same. No, the question wants when what is the same? Distance. So how do you find the distance from a speed time graph? Yes, it's actually the area under the graph, under the speed time graph. So the area under the speed time graph will give me the same distance. Got it, guys? So I give you guys some time to copy the one in green first before we move on. So I'm going to delete the rest of the working. So I'm going to draw out separately and fill in all the crucial information. So you guys can also draw it separately because right now there are too many information already on my graph. It's very messy. So I'm going to draw it out separately so I can see clearer. So one that is the car, the other one is the lorry. Okay, so right now we need to use a little bit of logic. So everybody, let's look at the screen right now. So we have three different zones. We have zone 1 right here. This is zone 1. We have zone 2, the one is in the middle. And we have zone 3, the last zone. So where do you think the overtaking will happen if you use a little bit of logic? Do you think the zone 1 will overtake or not? Will the car overtake the lorry in zone 1? Yes or no? No. Why? Because the lorry already had a head start of 10, right? The car is still accelerating, correct? So at zone 1, will the overtaking happens? What about zone 2? What about zone 3? Zone 3 very hard because it's already slowing down. If you use logic, for someone to slow down, do you think you can ever catch up? If you slow down. So obviously, I know that based on logic, zone 1, zone 2, and zone 3, where will the overtaking happens? Zone 2. So I know that if I use a little bit of logic, this is where the overtaking happens. Understand so far? Okay? So this is where I do the zigzag is something that the teacher cannot really teach you. It's a bit of logic. So you roughly need to know that the orange part is where the overtaking happens. Now I'm going to give you guys some time to copy all this down first. So the overtaking happens here. And this one, I do not know what's the time, so I let it be T at this particular point. Okay, so I let you guys copy first and do the color coding of all these different graphs, the separate graph for question C before we move on to the next question. So right now, the overtaking happens here. And we know that what is the overtaking? Overtaking is when what? Just now we just learned. Overtaking means distance is the same. It means that I need to go and find the distance, right? So how am I going to find the distance? So let's go and find the distance of the car first. And how to find the distance of the car? How to find the distance of the car? Yeah, so let's focus on only the car. So the car will be the one in red. And I know that to find the distance, it means that it's actually the what? Guys, not. It's actually the area under the graph. So the area under the graph is this red color part, right? And what is this red color part? What shape is it? This red color part. Very good. It's a trapezium. And what is the formula of this trapezium right here? So I have plus the what's A and B? A and B is referring to the who? Guys, what's A and B referring to? In the formula of a trapezium, the area of trapezium. What kind of sides? Huh? Yes, parallel. So what are the A and what is the B? The A is? Very good. It's T minus 20. What about the B? Huh? Yes, T. Next, what about the H? So here to here is T minus 20 and here to here is T. And what is the H? 15. So I put it in. Then now I just use algebra to simplify. So it's half. And what's inside the bracket? Not guys. Half. And what's inside the bracket? 2t minus 20 times 15. So I do the half times 2t minus 20 first. So half times 2t minus 20 will give me t minus 10 times 15. So that will give me an answer of so that is the distance of the car. So I give you guys some time to copy. After once you're done, we can move on to the lorry. So a lorry is the one in blue. All right, so let's go. Next is the lorry. So the lorry is also the same thing. It's the area under the lorry graph. So what shape is it? The moment you see this area under this whole line. So what shape is it? It's a rectangle. So what's the formula to find the rectangle? Length times breadth. So just put the bracket and the bracket. So what is the length? So the length we know is 10. Wrong. Length is not 10. What is the length? T. Yes. What's the breadth? So we have length and breadth. So T 10 will give me what? 10T. And we know the one in green, the one in green said that when you overtake means the distance is the same. So in math, what does same means? Same means what symbol? Equal. So I know that the circled one of this person is equal to the circled one of this person. And from there, you can solve and tell me what's your T value. Go and then let me mark. Okay, so right now, from here, you know that the time, if you solve it carefully, you need to have units. So the time is 30 seconds. Okay, so with that, we are officially done with question 1. Now let's move on to question 2. So I'm going to clear screen and let's move on to question 2. Now, question 2, you need to be very clear. What kind of graph is this? So if you do not know, you can always read the question. They already tell you. So I know that it's a speed time graph. So you need to have awareness on what kind of graph you are doing. Because sometimes it can be distance time, sometimes it can be acceleration time, sometimes speed time. There are 3 different graphs. So this is very clear. We have a speed time graph. So as usual, I'm going to highlight my motorcycle in one color so I can visualize better. And then after I'm going to highlight the car in another color. So I have motorcycle in one color and car in the other color. So right now, the question says that they want to find the what for question A. So how to find acceleration in a speed time graph? How do you find acceleration in the speed time graph? So acceleration in the speed time graph is actually the gradient of the slope. So of the motorcycle, which is the one in blue. So go and do that now and let me mark. So you have acceleration bracket M, but of course in the exam you cannot write M. You need to spell out the whole acceleration word and you need to spell out the whole motorcycle word. So go and do that now and let me mark your answer for A. So those who do not know, please go and take note. The units for acceleration is meter per second square. Go and write it in your notes now if you know that you're going to forget. So write it in your notes right now. The units is meter per second square. So right now, let's move on. They say that both motorcycles and car were beside each other at the start. At T seconds, the motorcycle overtook the car at T. So to find the overtaking, what do you guys know that we just talked about it? Overtaking means what? Nah. See, go and skip step. What does overtake means? Yes, same distance. You need to understand that first. And once you know that overtake means the same distance, so what does that mean? How do you find the distance? It's area under the graph. And remember, I told you guys, before we do that, we need to understand the zone. And it's not just any kind of graph. It's area under what kind of graph? Area under what kind of graph? Speed time graph. So right now, you need to understand the zone. So how to understand a zone? No one should be copying. You need to listen, because if you don't listen, then you'll forget about all this. This is the second time I'm teaching already when it comes to overtaking. So overtaking means, can you see where the intersection point is? So it means that it's split into zone 1 and zone 2. So where do you think the overtaking happens? In zone 1 or zone 2? Exactly, in zone 2. So I do not know where, okay? So I roughly maybe just put like here. Or maybe you can put here, up to you. Here will be too near. I won't want to put exactly at 15. Otherwise, later my mind will be tricked to think it's at 15, right? But if I put here, do you realize that if I put here, it's a little bit too fast because it's just caught up only. So where's the logically speaking? It should be around the wavy line. And I do not know what's the time. I'll let it be. You read the question. Did the question say X? The question say what already? T seconds. So right now, just now I've already taught you guys 1C. I want you guys go and do 2B right now and let me mark. I'm going to give you guys a clue, because at T, we do not know what is the speed. So what should I do? What is the coordinate of here? T, and I do not know what's the speed, right? But I have many other information, correct or not? So how do I find the speed of the motorcycle at T? How do I find this answer here, people? You all should know by now. Using what? Using, be more specific. Yes, using the same gradient. Using the same gradient what? Concept. So you need to go and use the same gradient concept and go and find out what is the speed of the motorcycle first before you apply and find the distance. Okay, so I'm going to do that now and let me mark. Okay, so the next question, we're going to move on. So later you guys let me check the 2B, whoever that couldn't finish, you stay back after class to do it. Now we're going to move on to question 3. So right now, question number 3, they say that this is a what kind of graph for question 3? So I know that this is a speed time graph, okay? So we have a speed time graph right here. So you double check. Yep, it tallies. We have a speed time graph. And then what did they say? Okay, that is a very crucial information. Mass accelerated from rest in 20 seconds. So this is the information that they give me. Miss is trying to tell me that at this point, it is resting. And then they gave me a number, and this number is not even on my graph. So what are they trying to tell me about that number? What's that number referring to? What are they trying to tell me about the number? What's the number referring to? What's that number referring to? Right now, you guys should know. We already went through a lot of questions on that. So guys, what is the biggest giveaway if you look at the number? 1.25 m/s squared. What is the biggest giveaway? The biggest giveaway is the units. And you look at the units. What is the units? Meter per second squared. So this is actually to tell you that this number is referring to the acceleration. So how do you tell the acceleration from a distance time graph? How do you tell the acceleration from a distance time graph? It's actually the gradient of the slope. So they're indirectly telling that the gradient of this red color one is exactly 1.25. So this is how everything is being linked. So right now, this is that it travels at this speed until t seconds before it comes to a stop at 80 seconds. So it stopped here. We come from a rest and then we have stopped at 80 seconds. So guys, if you look at this, what's the coordinate of this person? 20, comma B, and what's the coordinate of this person? Why do I find coordinate? Because I know from this clue, we are talking about acceleration, and acceleration is actually referring to the gradient. I know that gradient is referring to the coordinates. So far, so good? Understand now? So, they say find the values of V. So, by now, you know using the gradient concept. So, I want you all to go and do now and let me mark your answer for A part 1. Yeah, so if you guys do it carefully, you know that the answer should be 25, but you cannot write as 25. You need to write 25 per meter per second. So of course, guys, a very good habit is to fill in the answer. So I know the answer right here is 25. And then cancel, cancel, cancel. And this one fill in 25. Understand? Now the next one. They want you to find T. However, if you look at the question, we have one more information we have not used. So if you read the question, what is one more information we have not used? What is the information in the question we have not used? Yes, so we have not used the total distance. So 1.45 km, they say is the total distance. So how do you find the total distance from a speed time graph? Area under the graph. So where's the area under the graph? I want you guys to go and highlight in blue for me right now. Where's the area under the graph? Highlight in blue for me right now. So let's go. The area under the graph is actually this whole blue zone. But this blue zone, I cannot straight away do because I should split it up because I have an unknown called T. So I need to utilize this T. So I split it out into how many different areas, people? So I split into area 1, area 2, and area 3. Now, another thing you need to take note of is the units. So this is 1.45 km. A lot of students make this mistake because you must look at the speed. If you look at the speed determines the unit. If you look at the speed says meter per second, means that indirectly telling you that they're telling you two things from the speed. Meter per second means they're telling you that the what? What are the two things you can tell from the speed? That the what? Units of who? Two things. Number one, the units for who should be what, and the units for who should be what? Yes, the units for distance should be in meter. And number two, you know that the units for the time should be in seconds. So the speed is very important. The speed already tells you that the distance must be in meter and the time must be in seconds. But if you look at the question didn't tell you that the distance is in distance. Meter per second is speed. Guys, don't be confused between the units. You look at the question tells you that the distance, the unit is in guys, come on. The answer is literally on the screen. The units for the distance is in km. So we need to change this km into meters. So how do you change from km to meters? Yes, times 1,000. So you need to times 1,000, you get the answer in meter. Then you go and equate the area of 1, you go and find out. The area of 2, you go and find out. The area of 3, you go and find out. And equate this whole thing to the answer here. Then from here, you can solve, and you find the answer for T. Okay? All right. Now, next, you need to be very, very careful. The question says the average speed. Now, average speed, a lot of students make a mistake. They thought that I'm going to add the speed of the different journeys together is wrong. Because what did I teach you? How do you find average speed? So to find average speed, means I need the total distance of the whole journey divided by the total time of the whole journey, right? But you need to be very careful because right now they say that they want the average speed to be in km per hour. It means that the distance I find must change to km, not km per hour. Hello, girl, we're talking about distance. So it means that the distance, the unit must be in, guys, the distance, the unit must be in km. Yes, and the time, the unit must be in hours. So make sure that you go and convert because the question is in seconds. Okay? So I want you guys to go and do that also for B. Now for C, you guys should be able to do because this is already in the notes. So based on the notes, you all should be able to do C. All right? So that's it for question 3. So with that, you guys should be able to do question number 2 and question number 3. Next up, question number 4. Now, question number 4, we'll do this next lesson because question number 4 is a little bit more difficult. So I want you guys to do question number 2 and 3. Once you're done, you can go. That's all for today.